Salutations, mini mathematicians. Thank you so much for being here. We're going to be doing 5.3c, which odds and probability, chance, proportions. So our purpose today is to use the odds or probability of an event to answer questions. There's no reflection for this lesson. And you have a printout of this lesson that we're going to be completing together. So hopefully you got that notebook purpose written down. So 5.3c lesson again, odds and probability, chance, proportions. So when we look at odds, odds are a part to part, where probability is a part to whole. So let's take a look at the first one. It says a school basketball team wins 3 games for every 1 game it loses. So the odds that school basketball team will lose a game is 3 to 1. Because if it's the odds that it will lose, the first part is always about how many games they will lose. And the second part is the opposite. So it'll be how many games that they win. So is this part to part or part to whole? Explain any parts or wholes. So since we are winning 3 games to 1 game it loses, this is a part to part. And that's because this is we want to go 1 to 3. 1 loss part to 3 wins, which is another part. A whole would be like out of how many total games that they played. So what are the odds of winning? The odds of winning would be win to lose. So that's going to be 3 to 1. It says rework the statement above to state the probability of the basketball team winning. Would this be part to part or part to whole? Explain any parts or wholes. So the probability of winning, so we're going to use probability notation, capital P. Probability of winning would be, well, for wins 3 games for every 1 game it loses, that means there's a total of 4 games. We are winning 3 games, so winning would be 3/4 or 75%. This is part to whole because it is wins, number of wins, which is a part, to total games, which is a whole. Excellent job. So what's the difference between odds and probability? Because we will need these as we set up our proportions, knowing if it's part to part or part to whole. So odds are part to part, and probability is part to whole. They both explain the chance of something occurring. So it says to define odds in your own words. So let's think about odds as a ratio of the outcome occurring to not occurring. Perfect. So let's go ahead and solve some proportions setting these up. So it says define a variable for the unknown quantity, use a word ratio and a proportion equation to find the information needed to answer the questions, draw a model if helpful, answer in a complete sentence, and for problems with a star next to them, just answer the question. So there's a lot of things they're asking us to do here. They're asking us to define a variable, write a word ratio, set up a proportion, answer in a complete sentence. So let's see. This one has a star next to it. So the chance of getting heads when you flip a coin is a half, so it's a fair coin. What are the odds of flipping heads? So remember, for odds, we're thinking of heads to tails here. So the odds are 1 to 1. So part B doesn't have a star next to it, so we are going to have to do all those things. So define a variable, write a word ratio, set up proportional equations, solve it, and answer in a sentence. You flip a coin 80 times. How many times theoretically would you get heads? So our word ratio here, we're going to look at heads to total. So our variable x is going to be represented by the number of heads in 80 flips. So setting up a proportion, heads to total. You flip a coin 80 times, theoretically, how many times would you get heads? So 1 to total, because that's the probability of out of 2 flips, we should get 1 head. And here out of 80 flips, how many times do we get heads? Remember, we solve proportions using cross products. We're going to have 2x is equal to 80 times 1, which is 80. I'm going to divide both sides by 2 to isolate my variable to get x to be 40, which means in a beautiful sentence, you would expect around 40 head outcomes. Outcomes, flips, outcomes. So around 40, you would expect about 40. Perfect. So let's take a look next one. It says the odds of randomly guessing the answer right to a multiple choice test are 1 to 4. So again, it's not 1 out of every 4. These are odds. So odds are part to part. So this would be right to wrong if you think about this. So it's the probability of guessing the correct answer. So that would be right over right plus wrong. So that's 1 over 1 plus 4, which is going to get us 1/5. So we're using probability notation, probability correct. We use the same words they're using, is 1/5. So then if a test has 20 questions, how many of them would I expect to guess correctly? So again, let's use our word ratio here. A good word ratio that we can look at here would be correct to total, because they're asking about guessing correctly and it tells us our total number of questions. So we do want to use our probability here. We have to define our variable. X is going to be number correct out of 20 total, of 20 questions. So setting up our proportion to solve here, we're going to have 1 over 5 is equal to x over 20. Solve using cross products. We're going to have 5x is equal to 1 times 20, which is 20. I'm going to divide both sides by 5 here to get x to be 4. Oh, maybe you shouldn't have guessed. So you'd expect around 4 questions guessed correctly. You would expect around 4 correctly guessed. Kind of sad. Perfect. Go ahead. Let's turn that page. So number 3 says the probability of rain during April is 5/6. How many days can you expect rain during the month of April? So again, let's talk about a word ratio. So our word ratio here, they say what the probability of rain is. How many days expect rain during the month of April? Well, they don't give us another number. Oh, we know how many days are in April. The month of April, 30 days, has September, April, June, and November. There's only 30 days. Hope you know that little rhyme. It saved me a lot of times. Rain over total. X is going to be number of rainy days. April showers bring May flowers. Rainy days. So we are going to have 5 over 6. This is rain to total because it's a probability. Is going to equal x over 30. Remember, x is rainy days, 30 total days, keeping that ratio consistent. Solve using cross products. 6 times x is 6x. 5 times 30. Go ahead and simplify that. 6x equals 5 times 30. I don't know why I rewrote that again. 150. Just ignore that line. Take 1/6 of both sides or divide both sides by 6, and x is equal to 25, which is reasonable. You can have 25 days. So expect 25 days of rain. Lots of fun puddles. Perfect. I want you to work on 4, 5, and 6 does go on to the next page, and 7. We'll go over those, and then we'll finish 8 through 13 and 14 after that. So you're going to finish through 7, pause the video, finish through 7, and we're going to go over the answers as soon as you're ready. Okay, let's see how you did on 4 through 7. So number 4 gives us a 6-sided number cube. So remember, a 6-sided number cube is 1, 2, 3, 4, 5, and 6. So what's the probability of rolling a number less than 3? So that would be 1 or 2 or less than 3 out of all the outcomes, which is 1/3. So probability of a number less than 3 is equal to 1/3. I hope you used probability notation there. What are the odds of rolling a number less than 3? So odds would be number less than 3 to number 3 or greater. So it's 2 to 4. We have to simplify to be 1 to 2, just like we'd simplify fractions. Part C said if you roll the cube 27 times, how many rolls theoretically would you have a number less than 3? So number less than 3 add a total. X is number of rolls that you got a number less than 3. Make sure you defined your variable. So 1 to 3 is x over 27. Solve to get x equals 9. So you would expect 9 rolls to be a number less than 3. Very nice. I know these you could probably solve without the proportion, but you do need to follow the directions because these will get harder. Number 5, probability of spinning an even number on a spinner is 2/9. If you spin the spinner 91 times, approximately how many times would you expect to be even? Notice that word approximately because when you write your word ratio, even add a total, define your variable, number of spins that are even outcomes, and set up your proportion and solve, you get a partial number. So you expect an even number of outcomes around 20 times. We're not going to round up to 21. Because that would definitely have a different probability. So around 20 times. Ferris Bueller. It's a movie reference. It's late for school 3 out of 8 times. So what are the odds Ferris will be late? So 3 out of 8, 3 late, 8 total. So he's on time 5 out of 8. Or late to on time is 3 to 5. The odds are 3 to 5 that he will be late. So if we continue with this problem, looking at the next question, if there's 180 days of school, how many days will he likely be late? 67 or 68 school days. So late add a total, define your variable, set up your proportion. When you solve, you get 67.5. So around 67 or 68 school days, he can't be late for half a day. It doesn't work that way. Cami has a record for winning tic-tac-toe. Best game ever, right? 25 out of 82 times. So what are the odds Cami will win? 25 to 57 are the odds we will win because that's win to lose. And what's the probability of winning? Probability of winning would be 25 to 82 because that's win to total games. So then I'm sorry, there's not enough room for all the work for part C. How many games would she need to play in order to win 100 games? So win to total, X would be number of games total. 25 out of 82 equals 100 out of X. 25 X equals 100 times 82. We solve to get 328. So she'll need to play around 328 games so she can win 100 W's. Let's take a look at these cards. Whew. Let's take a look at these cards. You're doing a great job. Proud of you. 8 through 13 says a card's been drawn at random from the 20 cards shown below. Find the odds against drawing a card as the type described. We are just negative Nancy's today. So we have a total of 1, 2, 3, 4 by 1, 2, 3, 4, 5. So there's a total of 20 cards here. So the odds against getting an A. So how many are A's? 1, 2, 3, 4, 5. So that means 15 are not A's. So the odds against getting an A would be 15 to 5, which of course we reduce to, you got it, 3 to 1. Thank you. Go ahead, finish 9, 10, 11, 12, 13, 14, and we will go over those as soon as you're ready. Pause the video. Okay, hopefully you did a great job. No doubt that you did. Let's take a look at our answers. taking a look. Probability of a gray card simplifies to be 1-to-1. A white card then is also 1-to-1. A C, probability of not a C, 3-to-1. Probability of not 1, 2, or 3, 2-to-3. Probability of not B2, B3, B4, B5 reduces to 4-to-1. Please do not forget to reduce your ratios. Notice ratios do not have units. Unit rates have units. Ratios, no units. So the odds in favor to win of the Toonie Tunes winning the singing competition are 5-to-3. So win to lose. We have a chance here. What is the probability that the Toonie Tunes will win? So probability would be win to total. So 5-to-8. So probability to win is 5-to-8. Hopefully you used a probability notation to answer that. Thank you so much, mini mathematicians. You are awesome. Do your best. Be nice to everyone. And I will catch you next time. Video bar out.